So we're practicing writing the intercept form to start with. Just the intercept form, which looks like this. So do you know that A equals 2 and the x-intercepts are x equals 1 and x equals 4? What would the equation of the parabola be in intercept form? You have a parabola, the a value is 2, there's x-intercepts at 1 and 4. What would the equation be in intercept form? Yes. Okay, so I'm seeing lots of, I'm going to write the general equation out first, but lots of you got it. So y equals 2, x minus 1, x minus 4. Okay? That should be your equation. All right, erase, reset. Okay, so it's going to have an a value of 1, x-intercepts at -3 and +3. What is the equation in intercept form? Yep. 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 All right, so I'm seeing lots of, no, you don't need the 1, you don't have to have it. X plus 3, x minus 3. Awesome. Okay, next one. So an a of -2 and x-intercepts at -1 and -4. Yep. 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 Y equals. Okay, so -2, and then that's going to be x plus 1, x plus 4. Good. Okay. Okay, I'm gonna make it a bit tougher. So let's make a 2/5, and the x-intercepts are at 0 and 4. What would the intercept form look like? Yep. 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 Okay, so I'm seeing two different things and they're both right. And then some people with just, why are those the same? Why are these equivalent? X minus 0 is just x. So x minus 0 is just x. Good. Okay. Either one's fine for intercept form. Okay. So now we're going another step here. So I'll just have a be 1. One of my x-intercepts is 2 plus √3, and one of my x-intercepts is 2 minus √3. What would the intercept form look like? There's no x in yours, Molly. I can't read that part off. No. No. Okay, so if we follow it, you agree there'd be a 1 here that we wouldn't show? So if we follow this, x minus, now this is my x-intercept, right? Do you agree? So I'm going to put it in brackets. I'll use a different color brackets here. So here's my first x-intercept. And then x minus my second x-intercept. But I can simplify that a little bit further. Not much, okay, unless we put it into standard form, which is what our lesson's going to be about, going from this to standard form. But I can at least distribute the -1 in each, so that I don't have two sets of brackets, okay? So if I distribute that -1, I'm going to get x, -1 times 2 is -2, -1 times +√3 is -√3. And here I have x minus 2, -1 times 2 is -2, -1 times -√3 is +√3. So that would be the intercept form. Okay, we're going to try another one, just like that, and see if you can do the two steps, okay? Get to the answer. So, our step number will change, that's not a hard part, to -2, and our x-intercepts are going to be 5 plus √2 and 5 minus √2. The inner brackets. Yeah. And now you have to expand the negative to the next line down. Yes. You have 3 terms in there? Yeah. Yeah. Okay, good, we're done. So we've got the first step is the -2x minus inner bracket 5 plus √2, x minus inner bracket 5 minus √2. And then you want to distribute the -1. So y equals -2x minus 5 minus √2. X minus 5 plus √2. And this plus is because negative times negative is positive. Okay? All right, we're going to try one more, and then we'll go on to the lesson. Yeah.
I can't use like leave it without brackets. Probably doing and switching them. They do the same thing.
You're switching both. If you know that, then you're okay. So here's my x-intercepts are x equals -3 plus √7 and -3 minus √7. And let's change our a to +3. Okay, so a is +3. Our x-intercepts are -3 plus √7 and -3 minus √7. Careful with your expanding. Yeah, I'm not my eyes are so no, you need plus 3 because you're subtracting a negative. Okay. Yes. Yes. Good. Yes. Good. 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 Okay, we got it. So we got y equals 3, x minus negative 3 plus root 7, and x minus negative 3 minus root 7. So our answer would be x, and again, when you multiply a negative by a negative, you get a positive, so x plus 3 minus root 7, and x plus 3 again. Negative 1 times negative root 7 is plus root 7. Okay? All right. So we're going to move on with lesson 20. It's called Working Backwards. It's our last lesson for the quadratics unit, and then tomorrow afternoon we start trig. Okay?
Is trigonometry harder than this?
Not really.
I don't know.
Trigonometry.
I don't know. How long have you been running for? Okay, give me like another 10 minutes, and if it still is, then I'm call it to me. It will have been interested in, I think, 20 minutes. All right, let me pause it. No, there's a car out there that's been running for 20 minutes. Here it is. Maybe the battery wasn't working and they're trying. Yes, we don't. All right, so our last lesson for quadratics. Given the roots of a quadratic, we're learning to determine what the quadratic equation could have been that has those roots or solutions. Also, given the x-intercepts of a quadratic function, which is a parabola, what could the equation of the corresponding quadratic function be in standard form? Okay, so that's our goal, and we'll look at these. So the roots of a quadratic equation are -2 and 5. What could the quadratic equation be in standard form? And then it reminds us of what standard form is. So the reason I call this working backwards is because really that's what we're doing. We're starting off with the solutions, the values of x that make it true, and then we're working backwards to see what the initial equation could have been. So if these were your answers in the last note we just did, what would have the step before this look like?
First for the instructions, when the owner of a Honda with the license plate number ARSF888 comes to the office, that's a Honda, license plate number ARSF888.
Whatever. Yeah.
It's just not x plus 2 and x minus 5.
Yes. So we would have subtracted 2 on both sides. So our step before this would have looked like x plus 2 equals 0. Do you agree with that? And x minus 5 equals 0. That would have been the step before. Okay. What would have been the step before that? Bracket x plus 2 times bracket x minus 5 equals 0. Very good. Now how do I get from this form, Jack, to this form? Yes. So we get x squared minus 5x plus 2x minus 10 equals 0. And we're almost there, but we can collect the negative 5x plus 2x and make it negative 3x. So that would be the equation in standard form that would have those two solutions. Does that make sense? We're working backwards to see what the equation would be that has those roots. So the roots of a quadratic equation are negative 3 and negative 4. What could the quadratic equation be in the form ax squared plus bx plus c equals 0? So it's going to be the same. Take a question. I'll just give you a chance to try. So I would have started with x equals negative 3 and x equals negative 4. And step before that, x plus 3 equals 0, x plus 4 equals 0. And step before that, x plus 3 times x plus 4 equals 0. And then double distributive here to get it in the standard form on the left side. How many people got that? Yes? Any questions on any of the steps? Okay. The x-intercepts of a quadratic function are located at x equals 4 and x equals negative 1. The parabola passes through the point 118. Determine the equation of the quadratic function in standard form. Okay. So we're going to start with the best we can do right now with intercept form. So what would be the best you could write down for me in intercept form right now? And I'll give you a hint. We don't know A, so we still have to have an A there. But we do know R1 and R2. You know the x-intercepts. So x minus 4 times x plus 1. Does everyone see why it's x minus 4 times x plus 1? Yes? Okay. Now, we don't know A, but we do know that this point 118 is on this parabola, which means when x is 1, y is 18. So if I put 18 for y and 1 in for x, my only unknown would be A. It's a way to calculate the A value. Okay? So I can replace y with 18 temporarily and replace x with 1 temporarily in order to calculate the value of A. So 1 minus 4 is negative 3, and 1 plus 1 is 2. And what's A times negative 3 times 2? Negative 6A, good. And then how would I get A by itself? Divide by negative 6, good. So now I've got that A is negative 3, and that was the only thing I needed in order to get my intercept form, right? So if I come up here, I can now fill in the intercept form because I now know the A is negative 3. But it doesn't ask me for intercept form, it asks me for standard form. So how do I take it from intercept form and put it into standard form? Yep. Distribute. Okay, I'm going to save the negative 3 to distribute to the end. I'm going to do these guys first. Okay, and then I'll do the negative 3 at the end. Because it's the easiest one to distribute. So leave the negative 3 up front for now, and then do the FOIL or the double distributive. So that's going to give me x squared plus x minus 4x minus 4. Then I can collect the x and the negative 4x, make it minus 3x. And then my last step, I can distribute the negative 3 and everything. And then I will have it in standard form. Careful with the signs, negative times negative is a positive. And that would be your answer. Okay? So there's a lot of steps there. I wrote the intercept form that I had other than the A, subbed the point in so that I could calculate A, rewrote the intercept form, and then used algebra to put it into standard form. Okay? All right, the roots of a quadratic equation are 3 plus or minus the square root of 5. What could the quadratic equation have been in standard form? So yesterday, this would have been our final answer, x equals 3 plus or minus root 5. That would have been our final answer yesterday if we had to use completing the square of the quadratic formula to get our roots, right? It wouldn't have factored. Everybody agree? Let's put it up. All right, what did the step before that look like? Who remembers? Yeah? Yes, it did look like that. So we would have had our next step down would have been x minus 3 equals positive or negative root 5. Okay, because I remember we would have added 3 over at the end. That would have been our step before. So we're working backwards, remember? So the step before would have been x minus 3 equals positive or negative root 5. What do you think we would do next? Yes, put the exponent back. Very good. So I'm going to put the exponent back on this side, which means I also have to put it back on this side. Whatever you do to one, you do the other. Great, guys. Now remember, my goal is to get a quadratic equation that looks like this. So I want to write this x minus 3 squared as x minus 3 multiplied by itself. Now, what is this side? Yeah. Close. Root 5 times root 5 is the root of root 25. Root 5 times root 5 is the root of 25, which is 5. So this squared undoes the square root. The squared undoes the square root. Okay, and it doesn't matter, like positive root 5 times positive root 5 is root 25, negative root 5 times negative root 5, and negative times a negative is also positive, so it doesn't matter. Okay? The squared undoes the square root and the plus or minus. Okay? We still want it to look like this, so now we're going to have to do our distributive, double distributive here. And then we want it equals 0, so subtract the 5 on both sides. So our question would have been x squared minus 6x plus 4 equals 0 as roots. X equals 3 plus or minus root 5. Okay. Any questions about that one? Okay, next one. The roots of a quadratic equation are negative 2 plus or minus 3 root 7. What could the quadratic equation have been in standard form? Answer would have been yesterday, x equals -2 plus or minus 3 root 7. What would the step before that look like? Yeah, Jacob. Divided by? Subtracted. So in our case, if you've got a -2 there, you add 2. So this side would have looked like, the step before this side would have been x plus 2 equals positive or negative 3 root 7. Okay? That's how we got the -2 there, because we subtracted 2. Now we need to have it squared on both sides. So this side squared and this side squared. Okay, so this side squared is just going to be write it out twice and expand. How do we square 3 root 7? Yeah.
Can you go back to how did you get 3 squared root? I don't know how to explain it, but like it's 9 times 7.
Very good, very good. So if you can do it in your head, you're good at with mental math, perfect. If not, you can multiply these. Okay? So squaring something is multiplying it by itself. Is everybody good with that? So 3 times 3 is 9, like Sebastian said. But what's root 7 times root 7? 7. Okay, it's root 49, which is 7. So it's 9 times 7, which is 63. Okay? And then we got to do the algebra. So we're doing the double distributive here. X squared plus 2x plus 2x plus 4 equals 63. Subtract the 63, so we've got equals 0. And collect the x ending. So x squared plus 4x minus 59 equals 0. Okay, so warning for the next two, write small. Start on one side, leave room on the other. I've got a third one on backup if we want to do another one just to make sure we've got it. So. No, it just means we want to make sure everybody's on the same track before we.
Why do they have to do this? Why is this important?
Okay, so there's a list of things, Jeff, that you need to know for grade 11, and I'm following the list. So it's on the list of what the critical things you need to know for advanced functions are. This is one of the. Okay, so this is what I get to leave out, this part. After today I've covered this entire chunk, which looks like the longest that it is. Then I'm going to do the trig, so I'll have covered the whole trig chunk. And then last we'll do so on and I'll try to cover all of it. So you'll have it all, but all the stuff you need for next year. So there's no frills. Nothing you don't need for next year, and I'm promise. Okay? They made these so everybody would do the same thing with their limited time.
And this is the necessary stuff. I don't even want
It's not necessary. All right, so with this one, the x-intercepts of a quadratic function are -2 plus root 6 and -2 minus root 6. So you guys know how to start off with the intercept form. That's what we did with the whiteboards. So what would your intercept forms look like if we don't know A? We just leave A in there. Okay? minus -2 plus root 6. X minus -2 minus root 6. My first step, I put it in intercept form. Okay. Second step, I'm going to distribute that negative. So this is kind of my go-to intercept form would be my second line down here. We'll come back to it later. So that's my intercept form, which isn't very pretty, and that's why they want it in standard form. Okay? Everyone see that's intercept form except we don't know A, right? We don't know A. But, so they have to give us a way to find A. So what did they give us in order to be able to find A?
X and Y.
They give me a point, right? So a point that I know is on the parabola is when x is -2, y is 12. So if I put 12 in for y and -2 in for x, my only unknown will be A. Okay? So I'm going to do that. I'm calculating A here. So 12 equals A, -2 plus 2 minus root 6, -2 plus 2 plus root 6. -2 plus 2 is 0. So in this bracket, I'm just left with -root 6. And then the other one, I'm just left with positive root 6. What's -root 6 times positive root 6? No, that would be adding. If I was adding them, I get here. I'm multiplying them. Yep. -6, good. Okay, so if you don't see that, remember this is, so a negative times a positive is a negative. And then you can multiply what's under the root signs together. And then the square root of 36 is 6, so that's what gives you the -6. Okay? Good job. Now I need A, so I'm going to divide both sides by -6. And that gives me A of -2. Yes? Got A to be -2? Everybody gets A is -2? Okay, so now you're going to the other side of your page, and you're rewriting this stage here, the second stage, with A being -2. So y equals -2 x plus 2 minus root 6, x plus 2 plus root 6. And we want to take it, this is intercept form. So now we know A, we've got everything we need for intercept form, but we want to put it into standard form. Which means I have to multiply these two brackets together. So I'm going to leave the -2 out front. So this is like triple FOIL. Okay, so I'm going to multiply the x by each thing in the second bracket. Okay? So carefully, slowly, x times x is x squared. X times +2 is 2x. X times positive root 6 is root 6x. Okay, now I'm going to multiply the 2 by each thing in the second bracket. Okay? So in order to expand them, I have to multiply each term in the first bracket by each term in the second bracket. So now I'm going to get plus 2x plus 4 plus 2 root 6. 2 times root 6 is 2 root 6. Okay? Now I'm going to multiply the negative root 6 by each term in the third bracket. So there's going to be 9 products that you do when you expand them. Okay? So negative root 6 times x is negative root 6x. Negative root 6 times positive 2 is negative 2 root 6. I had to go on to the next line, sorry. Negative root 6 times positive root 6. Negative 6. Okay, if you do everything right, the root things add up to 0. Okay, so find something that has a root. Root 6x, see how it's a positive root 6x? See if there's a negative root 6x somewhere in your bracket. Is there? So I can cross those off because they add up to 0. Is everybody good? Positive root 6x minus root 6x is 0. Is there anything else that has a square root in it? 2 root 6. See this positive 2 root 6? Is there a negative 2 root 6 somewhere in the same bracket? Yes. So positive 2 root 6 and negative 2 root 6 add up to 0. So what's left, if I start collecting, I've got my negative 2. Is there any other x squared terms? No. Is there any other x ending terms? Positive 2x and another positive 2x gives me positive 4x. So I've done. And then I have positive 4 and negative 6, just plain numbers. When I collect them, positive 4 and negative 6, I'm going to get negative 2. And then finally, your last step is to distribute the negative 2 through. So y equals negative 2x squared minus 8x plus 4. Okay, what I want to show you on the Desmos is that this graph and this graph lie right on top of each other. Okay, so you can see that they actually are the same. Obviously, this looks way easier. Okay, so in order to do that, I'm going to take a picture of it and then type it in. Okay, my glasses on. All right, so if we go to Desmos, we can see what these parabolas look like. So our first one in intercept form is y equals negative 2x plus 2 minus square root of 6. And then x plus 2 plus square root of 6. So that's what our parabola looks like. I can shrink it down so you can see. Looks like it's got a vertex at what is this going by? 2, negative, well, I can just click on it, negative 2 and 12. Okay, and now I'm going to type in the standard form. So y equals negative 2 x squared minus 8x plus 4. And they lie right on top of each other. Okay, so we took the very complicated intercept form and turned it into the standard form. And they're the same, just written differently. Okay? Everybody good? All right. Going back to this one. All right, so our next question. Do you guys want to try this one on your own? Yep. Okay, so I'll pause. Okay. All right, so a lot of you are getting as far as this. If you want to keep going on your own, go for it. But I've got lots of people writing this down as their first step, which is lovely. Okay, and then your next step would be x minus 5 minus root 3 and x minus 5 plus root 3. So hands up if you were able to get there. Okay, so now is where we would put in x and y, correct? To find a. So in for y, we're going to put negative 3. And in for x, we're going to put 2. So that makes it a little harder because when we put in our number last time, we ended up making a 0 pair. But that doesn't happen here. But we can still make it less. So we can do 2 minus 5 is negative 3 minus root 3. And 2 minus 5 is negative 3 plus root 3. So now we have to do FOIL on these, okay? In order to figure out what this number actually is. Because we can't collect the different endings, this radical and an integer. But we can multiply. Negative 3 times negative 3 is positive 9. Negative 3 times positive root 3 is negative 3 root 3. Negative 3 times positive root 3 is negative 3 root 3. Now the inner here, negative root 3 times negative 3, negative times a negative is positive 3 root 3. Okay? And then negative square root of 3 times positive square root of 3 is negative square root of 9, which is really just negative 3. Does everyone see that? The square root of 9 is 3. So I can change that to minus 3. Bracket. So then I have negative 3 equals a. Now this forms a 0 pair. Negative 3 root 3 plus 3 root 3 is 0. So they add up to 0, and I'm left with 9 minus 3, which is 6. Oops. And then I want to get a by itself, so I'm going to divide both sides by 6. So it's going to turn out that a is negative 1/2. A is negative 1/2. Okay? So now I come up and do the next part. So I go from this line, but replace a with the a that I know I have, so y equals negative 1/2, bracket, x minus 5 minus root 3, x minus 5 plus root 3. Now I'll pause it. Does anyone think they've got the 9 multiplications? On their own? 9? Yeah?
Okay, I'm gonna attempt this.
Yep, that's good.
X squared
Yep,
minus 5x
yep,
plus root 3x
yep,
minus 5x
yep,
plus 25
yep,
minus 5 root 3
yes,
minus root 3x
yes,
plus 5 root 3
yes.
minus 3.
Awesome! How many people got all 9? That's awesome. Way to go, guys. Really good. Okay, so that's awesome. So now you want to look for anything with a root because you know those are going to be the ones that have 0 here. So I have a plus root 3x. I'm really going to want to have a minus root 3x. And I do. Okay? I've got a minus 5 root 3. So I'm going to want to have a plus 5 root 3. And I do. Okay, so those are basically gone now. Those 4 terms. So now I'm going to collect what's inside the brackets. There's only one x squared term minus 10x. So those are taken care of. Plus 25 minus 3 is plus 22. And then the last step is to distribute the negative half. So that's going to give me negative 1/2 x squared plus 5x, because negative 1/2 times negative 10 is positive 5, okay? And then negative 1/2 times positive 22 is negative 11, okay? All right, we're going to do the backup one, so you have the whole back side to work with, and I will give you the parameters. So we want, it's the same question. So x-intercepts are x equals negative 3 plus root 2, and x equals negative 3 minus root 2, and it goes through the point negative 1/6, and you want to get the equation in standard form. Go through all the steps. Find A, put it back in, get the equation in. So first stage is y equals a x minus negative 3 plus root 2, x minus negative 3 minus root 2. Then we're going to expand. So x plus 3 minus root 2, and x plus 3 plus root 2. So that would be my go-to line for intercept form. Now I'm going to replace y with 6 and x with negative 1. And now a is my only unknown. Negative 1 plus 3 is 2. So now I can do FOIL. So that's going to give me a. 2 times 2 is 4. 2 times positive root 2 is positive 2 root 2. Negative root 2 times 2 is negative 2 root 2. And negative root 2 times positive root 2 is negative root 4, okay, which is negative 2, right? The root of 4 is 2, so that's going to be negative 2. These add to 0. So I've got 6 equals a times 2. Divide by 2 to get a. And we've got a equals 3. Now we know a equals 3. We want to take this line and rewrite it with a being 3. So y equals 3 x plus 3 minus root 2 x plus 3 plus root 2. And now is where the 9 multiplications come in. Okay? So you've got the 9 of them. 3 here, 3 here, and 3 here. Anyone want to give me your 9 multiplications? Got there? Yeah?
Right, okay, we're gonna try this.
Yep.
X squared
Yep.
plus 3x
Yep.
plus root 2x
Yep.
plus 3x plus
Yep.
9
Yep.
plus 3 root 2.
Yep.
Sorry, I can't even read my own writing. Minus root 2x
Yep.
minus 3 root 2
Yep.
minus 2.
Yes. Very good. Yay! That's a feat. Okay, so then let's look and hope that our root 2 or root things cancel out. So we've got plus root 2x and minus root 2x. Good thing. We've got plus 3 root 2 and minus 3 root 2, which is a good thing. Okay, so we've done it probably right. So y equals 3x squared plus 6x plus 7, and then distribute the 3. So y equals 3x squared plus 18x plus 21. Okay? All right, so I have practice for you.